Yes, we are continuing here. The video is like a single input gate primitives. Okay, here the previously we are discussing about this initial begin keywords. The initial begin keyword is like if you are using only initial keyword, then it means only single statement is there for executing. For example, if you have more than one single statement, means like more than one statement and multiple statements you want to be executed sequentially, then you can write initial begin keyword. Okay, initial space begin, and after that I am assigning a comma b is equal to 0, and after that I am using the monitor, otherwise the display, for printing the output on my screen. Okay, next I am using a for loop. So in Verilog code we can use like control statements and like condition statements, for loops, while loop, and also we can use if, else if, like that. Okay, so for I is equal to 0, I less than 10, I is equal to I plus 1. So I for is beginning here, and it is going to be the hash 1 a is the delay of the time, and a is less than or equal to, and I am using a random is a keyword. I am random keyword means it will take either 0 or 1, it will take the input randomly, and b is also taking it is a either 0 or 1, it is taking it randomly. Okay, so like here it is going, and it is I am ending the for loop, and after that I am ending this initial begin, and after that I am ending the module. So here we will get the output of what is not, what is above. Okay, uh, in this code. Next, multiple input gate primitives. So previously we have seen single input gate primitive, and here the multiple input gate primitive. So in multiple gate primitive it is vice versa of the single input gate primitive, means here we have the multiple inputs, but we have a single output we will produce. So by using this AND, OR, XOR, NAND, NOR and XNOR gates, the syntax is here. See the syntax: module and or XOR gates. I am implementing AND gate or and XOR gates. I am writing the Verilog code here. The outputs and input ports are here, and after that I am taking directly the keyword AND. Okay, C comma A comma B. C is the output and A B are the inputs. Here D is the output and A B are the inputs. Here E is the input and sorry output, and A B are the inputs. Okay, XOR and OR I am implementing here. Now I am writing a test bench code for this thing. Test bench code is nothing but, don't worry, it is a Verilog code. Okay, for expand means for testing this logic. Okay, so now I am creating another module, means like a module with a name. Next I am taking the inputs as a register data types and outputs as a wire data type, means net data types, and after that I am creating an instance variable, means instance object of this particular module. So here I am creating an instance. So C comma D comma E comma A comma B. Okay, so now I am starting with initial begin, because I have a multiple statements for executing sequentially, so that's why I am using here initial begin. So A is equal to 0 I am assigning, and B is equal to 0 I am assigning. So with the one unit of time, means like a millisecond unit of time, I am taking the inputs A is equal to 0 and B equal to 1, like this. So after that I am ending this initial begin. Okay, next I am again creating like for displaying this, I am writing initial begin, I am displaying the output of each and every this C is equal to ornaments output of A, C, D and E output, means AND gate, OR gate and NOT gate inputs I am AND gate, OR gate and XOR gates input outputs I am displaying by the aspect of time also. So when you are going to be implement this code, then easily you will produce the output. So you just write this code by using a Verilog software, and already I shown some example in some videos. Just try this code for getting an idea. Okay, next one is last one is the switch level modeling. So the switch level modeling is provides a level of abstraction between a logic and analog transistor levels of abstraction. So logic and analog transistors means we know the switch level modeling means here the switch on or off. It can be mostly based on that like NMOS and PMOS transistors. Okay, so sometimes switches are like unidirectional, and sometimes switches are like bidirectional, and sometimes it can just resistive, and it sometimes it does not have any resistive. So based on that, we have the positive gate such as NMOS transistor, and those switches on with the negative gate such as PMOS transistor. Already we know these things, we have studied previously. Okay, so for the writing NMOS transistor switch level implementation of Verilog code, that is NMOS N1. Okay, out comma data comma control. Here we are giving this. This is a syntax. Just remember this thing. And for PMOS, use the keyword PMOS. Just create one of the. Here there is no need to create any module. Otherwise, there is no need to write anything. Okay, just write this thing. Just we can solve one problem on the switch level primitive also. Already we solved the problems on data level modeling. After that we will solve the problems on gate level modeling and switch level modeling also. Okay, these are the level of abstractions. Means when we are implementing a Verilog code on different levels of abstractions, like mainly we are discussed about of three levels: data level modeling, next one is gate level modeling, and switch level modeling. So based on that level of abstraction, level of implementation, we can write that Verilog code. Thank you.